Okay, so we looked at the combined gas law before in our previous videos, and that tended to allow us to figure out what happened when things changed. Well, what happens when you're just dealing with trying to find a single state, a single pressure or volume or temperature? Well, we've come up with an ideal way to find that. We call it the ideal gas law. The ideal gas law is pressure times volume is equal to N, the number of moles, times the rate constant, which is the rate at which those molecules vibrate inside, times its temperature. So there are some rules we have to follow with the ideal gas law. So let's set that up. So P, which is for pressure, pressure must be in atmospheres. It has to be in this unit. Okay? We have a lot of units for pressure. There's atmospheres, there's torricellis, mmHgs, kPas, kilopascals, or psis. We have to convert them always to atmospheres. V is for volume. Volume must be in liters. Although we tend to work in milliliters, for this formula, it must be in liters. N is equal to the number of moles. It's the amount of molecules there. And the amount of moles has to be in moles. And we know moles is grams over molecular mass. Okay, so this has to be in moles. R is a constant. And if it's a constant, we have a set number we're going to use every single time. And this is going to be 0.0821. Now technically it does have units, and the units we could find if actually we just solve this equation. So we're going to come back to that in a second, and then I'll fill in the units for R. And then T stands for temperature. And for temperature, it has to be in Kelvin. So if we wanted to know what a constant's units are, let's do that. So we have PV equals nRT. Pressure is in atmospheres, ATM. Volume is in liters. Is equal to moles times our R, which is what we're finding, times Kelvin. So if we solve for R equals atmospheres times liters over, and then we divide by moles times K. These are our units for our constant. And to be honest, most times we're not going to write these in as a shortcut, but realize that it's officially, this is what our units are. If they're not in this unit, you must convert. Otherwise, it's not going to work out right. All of these are set for that units. So let's get an example of the ideal gas law. So, example 1. Let's find the mass of chlorine gas found in a 3-liter container at 650 mmHgs and 27 degrees Celsius. Okay, so let's work through this problem. Let's list out what I have. It's very helpful to get that out of the word problem. So the first thing I know is I'm dealing with chlorine gas. Chlorine gas is Cl, but it's by itself. Anytime it's by itself, you must worry about diatomics. Is chlorine a diatomic? And we'll find out. If you look at it, we have H, N, O, F, Cl, Br, and I are all of your diatomics, are H7. So it is diatomic. That's going to help us. We have pressure, volume, and temperature all need to be found. I have 27 degrees for temperature, degrees Celsius. I have a volume of 3 liters. And I have a pressure of 650 mmHgs. So my first steps is I need to convert. Temperature is not in Kelvin. So plus 273. That makes this equal to 300 Kelvin. Must be in Kelvin. Liters, I'm fine. Pressure, pressure is not in ATMs. I want it in ATMs. I know 1 ATM is equal to 760 mmHgs. So I'm going to take this number, multiply by the unit I want. I want atmospheres. I already have mmHgs. So mmHgs will cross out. I'm left with 650 times 1 divided by 760 will give me my units of pressure. So it's 0.855. Okay. So let's plug into PV equals nRT and start. So I have a pressure. .855 atmospheres. That's my pressure. My volume was 3 liters. I don't know my number of moles. R is 0.0821, and my temperature was 300. This will allow me to solve for my number of moles. Let's work that out real quickly. So times 3 divided by 0.0821 divided by 300. So I currently have 0.10417 moles of Cl2. I know that moles equals grams over molecular mass. I'm trying to find the mass. I'm trying to find grams. So grams is equal to moles times molecular mass. Okay, so what's the molecular mass? Well, I have Cl2. The molecular mass is 35.5 times 2, or 71. So grams equals 0.10417 times 71. 7.40 grams of Cl2. And there you go. You now found that the mass of chlorine gas that's found in a 3-liter container with this pressure and this temperature is going to be 7.40 grams of gas. And so this is a way we just found out how much gas is in a container simply by knowing the basic measurements. With that, we can do a few other things with these problems. You'll see a few more. This is a good intro level. Please keep in mind both the formula and our constants. We must remember our units are required to be in these exact ones for our problems to work. Okay, good luck.